Okay, so this is pre-calculus, regular pre-calculus, chapter 1 test corrections. So this is the front side. I'm only going to be doing MCQ. So the first problem is, what transformation of the parent function f equals x squared is the function f of x equals negative x plus 2 squared? So what you want to do first is kind of see what's different between the parent function x squared and the difference between f of x equals negative parentheses x plus 2 parentheses squared. So there's a negative in front of the x and it's on the outside, take note of that. And there is a plus 2 on the inside. So we know from what we learned in class that the negative on the outside creates a negative y. So if the y is negative, then the whole graph flips across the x-axis. That's why I wrote that there. And the 2 in the inside of the parentheses, that's for horizontal shifts. And you remember that you have to do the opposite. So you're not going to add 2 and move to the right. You're going to move to the left. So the answer should be C. And for number 2, find any vertical asymptotes. So you already know that you should take the bottom of the function, the denominator, and you should set it equal to 0 or not equal to 0, which is what I did here, and you're going to solve for x. So what I did was I moved 1 to the other side and I divided it by 2, so x cannot equal 1/2. Because if it does equal 1/2, in the denominator, the function would be 2 times half minus 1. Half of 2 is 1. So what you would get on the bottom of the function would be 1 minus 1, which is 0. And you can never have 0 as a denominator in any fraction. So the vertical asymptote is half, because at that point, no point exists. No y value exists. So it should be A. So for number 3, you have to determine which of the following rational functions has the following feature, has a horizontal asymptote at y equals 3. Okay, so you kind of have to know a little bit about the horizontal asymptote rules. So there's a couple rules concerning those. So what really matters is the degree of the x on the numerator and the denominator. So for A, you can see that 3x minus 1 over x plus 9, those x values on top in the numerator and on the bottom in the denominator, they're both to the power of 1. So they have the same power. So the rule for functions that have the same power on the numerator and the denominator is that you can find the horizontal asymptote by just taking the coefficient of the highest x value. So what I mean is, in A, you could just take the coefficient of the highest value of x is 3, right? And on the bottom, what's in front of x? It's 1. So you would have 3 over 1. So that's how you find the horizontal asymptote for that type of function. So the horizontal asymptote for A should be 3. Another example is, let's see, C. Why C doesn't work? C does not work because although they do have the same power, that means that you could divide the coefficient of the highest power of x, right? So you have 1 divided by 1, right? You got 1 from the top because 1 is in front of x and 1 is in front of x in the denominator as well. But 1 over 1 equals 1, and that would mean the horizontal asymptote equals 1. And we're not looking for a horizontal asymptote of 1, we're looking for a horizontal asymptote of 3. So A provides that horizontal asymptote that we are looking for, so A should be the answer. For number 4, you just kind of have to know what type of functions there are from that one packet a while ago. Graph number 1 is a cubic function, and the parent function of a cubic function, the most basic form, is y equals x cubed. And graph number 2 is the absolute value function, and that one is the absolute value symbol with x inside. And this one is a sine function, and you know it's not a cubic function because it keeps going up and down, up and down. And the highest point and the lowest point is 1 and -1. That's a characteristic of sine functions. And the fourth graph should be the greatest integer function. You can tell that the fourth graph is a greatest integer function because it has the holes there, the open-ended circles. And for the last question, number 5, which of the following functions have an inverse function? I actually graphed each one on a graphing calculator. With that, I visually did the horizontal line test. That's the one where you kind of imagine, like, you put a line horizontally, like all throughout the graph, and if it touches 2 points, that means it's not going to have an inverse function. But if it only touches 1 time on the graph, on every horizontal line you make, then that means that it's going to have an inverse. So I did this for all of them, and the answer should be D, because after I graphed that one, I did the horizontal line test, and it only went through 1 point per horizontal line I drew. So yeah, that is the multiple choice questions.
All right, so thanks, Nicole. So let's go over question number 6. Make sure to show all your work and box your answers. Given number 6, f of x is the square root of x and g of x is the square root of 5 minus x. Number 5, find f plus g. So I need to add these two functions. You realize that you can't add the square root of x and the square root of 5 minus x. So what you can do here is you can just substitute in your numbers. That tells you your x value 2 here. Put in your 2 for your x, 2 for your x, 5 minus 2 is 3. Notice these are not like terms, and then you have square root of 2 plus the square root of 3 is your exact answer. Question 6b says find the domain of f plus 2 of 2. So I need to find my most restricted domain. So if you look at this problem here, if you inside the radican, that's the number inside, has to be a positive number or equal to 0. So x is greater than or equal to 0. And, keyword there, 5 minus x, we're going to set that greater than or equal to 0. So I subtract 5 and I divide by -1, which flips the inequality sign. So x has to be less than or equal to 5. So then if I put those two together, because it has and, that means I could pick any number between 0 and 5. Closed circles is bracket 0 to 5. Question number 6c, f divided by g. So I just substituted in there. Don't be tempted to cancel your x's. In order to get full credit, though, you have to also include its restricted domain, which is x cannot be 5, because if you put in 5 here, 5 minus 5 is 0. Anything divided by 0 is undefined. And because you can't pick 5, that means the domain of f divided by g is what we had above, but you can't include 5. So you can include any numbers from 0 to 5, but not including 5. So 0, 1, 2, 3, 4. Question number 7. Let's look at some student work. Here's some student work. Has quadratic formula. Good. Substitutions. This is good. That's why I put a check mark. 16 minus 32 is a negative number. So if I allowed you to use your calculator, use it. This student, they did factor out a 2. 2 times 2 is 4. But 2 times 4i would have changed to 8i. That's why I circled that right there. That should be 2i. Another common mistake, not writing down the quadratic formula correctly. Quadratic formula has a minus sign there. So your a value is equal to 1, b is -4, and your c value is equal to 8. Pay attention that it said equal to 0. There's my quadratic formula. Always write down the formula first. To the substitution, b is -4, a is 1, and c is 8, and then a is 1. 16 minus 32 gives you -16. Remember, the opposite of -4 gives you a +4. The square root of -16 is 4i. So I have 4 plus or minus 4i over 2. This is not simplified. So I'm going to take out a GCF. Both look at this 4 and the 4 both have a 2 in common. The reason why I'm not going to do a 4 is because the denominator also has a 2. Cancel those, and then 2 plus or minus I is your answer. The extra credit questions was what city did I grow up in? That was Fullerton. And how many years I've been teaching? That is 13. All right, so let's go over this problem. 9a, graph the piecewise function here. So I have x squared plus 1, and my restricted domain is x is less than or equal to -1. So if you draw a parabola here, it's shifted up 1 unit, and then the parent function is at your vertex would be right 1, up 1, but then if you put in 2, it would be 2 squared plus 1, so that give you a total of 5. so it'll be up here. So 0, 1, 1, 2. And then same thing over here. You can just substitute in your x values of -1. -1 squared is 1. 1 plus 1 is 2. That's why I would point here. And then -2 squared gives you 4. 4 plus 1 is 5. So notice how there would my parabola be, but I'm only restricting it at x is less than -1. So that's a closed circle. Now you may have been lost a point for actually not drawing correct points on your quadratic function. And remember, I believe I let you guys use your calculator, so there should have been no excuse because you can use your table function to graph that. Our second part of our piecewise function says x plus 4 is -1 less than x less than 2. So first I'm going to graph x plus 4. So positive 4 is my y-intercept. Coefficient in front of x, that means there's no slope, so that's just 1. So rise of 1, rise of 1, rise of 1, rise of 1. You can do this direction too. That would be -1, down 1. And so I want you to start at -1. So there's my open circle because there's no line there on my inequality. And then I need to go to 2. There's also an open circle there. And my third piece of my function says f of x equals 5. Well, f of x equals 5 is the same thing as saying y is equal to 5, where all your values of y or f of x are all 5s. You make up your x values and you can graph that. And I'm starting at 2 with a closed circle, and that's what your graph looks like. So that one's out of 4 points. If you got at least one of those correct, I gave you 2 points. Again, you probably lost a point. If you didn't get full credit, lost a point on your accuracy of your parabola. This problem above, number 9b, says continuous or discontinuous. If discontinuous, what type? So it's discontinuous because I pick up my pencil to go from the purple to the blue. And then it's a jump because there's a jump right there. Let's look at some student work. Here's student work where I gave 3 points because the accuracy of their parabola. That should have been 2, 5. Another example of student work where I put an X there and only give them partial credit because the accuracy, again, of your parabola. All right, here's some more student work showing that the second piece, x plus 4, the student has a positive slope but doesn't go through this point. So that's incorrect. This parabola is also graphed incorrectly. I put a check here to show that this is the only one that's graphed correctly. This one just tried to show a parabola, incorrect, 1 point for trying. Student didn't use ruler but didn't deduct a point for that, but definitely lost a point for the accuracy of their parabola. Notice how that here at -1 you shouldn't have 2 graphs. So question 10a, graph the function and make sure to include your asymptotes. If you just graphed it and from the graphing calculator and didn't prove to me algebraically how to found the vertical or horizontal and it was accurate, I give you 2 points out of 4. To find my vertical asymptotes, I'm going to take my denominator and set it not equal to 0. Recognize that this is factorable, or you could have added 36 to both sides. Or if you factored 0 product rule, you got x equals -6 and +6. Those are my pink lines, pink box. My horizontal asymptote, you're going to look at your exponents, your highest degrees. Notice how there was just 1 over, so there was no variable. So you can add an x to the 0 power because x to the 0 power is just 1, so that means you have 0 and 2. And when you compare those two, you have the top degree and the bottom degree. 0 is less than 2. Therefore, you will always have a horizontal asymptote at y equals 0. I need to see that. Mine is in blue, a dotted line there. And then on your next quiz or test, you're going to have to graph this without a graphing calculator. So you would have to pick values left of -6, some numbers in between 6, and some values greater than 6. Now you'll notice you have 3 parts to the graph here. 1, 2, 3. And if yours only comes out with 2, you should definitely zoom out to make sure that you get it all. Let's look at some student work. Here's some student work. Student didn't recognize where the horizontal asymptote was. I think the student just graphed x squared minus 36, but also has it graphed down, incorrect. Here's an example of a full credit, question number 10a, looks good. Interesting enough, the student was using guess and check to figure out the values of x and didn't come up with -6. That was incorrect with an X, and they had a correct graph, so I assume they got 1 vertical asymptote, and the general shape of the graph was correct. I gave them 3. Here's an example where the student didn't recognize that there was a third part of the graph on the left side. All right, for 10b, it says find the domain of question number 10a above. So we're going to look at this graph. So assuming you graphed it incorrectly, domain means the x-axis, and we're starting from the left to the right. So over here, you're going to start there at the negative infinity. I notice that this number here, -6, the graphs don't touch, so you're not including -6, and that's a parentheses. And then your graph starts again at -6, but not including because it's not touching, goes all the way to 6. And then restarts here at 6, and then goes towards infinity. If you got one of these right, I give you 1 out of 2, and then get full credit. That's 2 points out of 2, and that side was 23. Let's look at some student work. All right, this is a good one. This one was incorrect, but it looks like the student was, because their graph was incorrect, they only got it from here towards infinity, but did not include even the asymptote. Remember, you have to somehow account for not including that number. I gave this student 2 points because although they were algebraically incorrect, solving for the, no, that is correct. I mean, it's the wrong version. Let me check. Oh, wrong version. All right, here's some correct work of a student work on this graph. Graph is in 3 parts, so 1, 2, 3. All right, this student got an asymptote here, crazy graph, and negative infinity to 6. So they at least knew that the graph was there, but not one of our 3 that we're looking for. Hope these test corrections are helpful for you.